Assalamu alaikum. Now, in this video regarding a video tutorial, we shall discuss about how to compute the quartile, deciles, and percentiles. Then we shall see how to compute and how to interpret the coefficient of skewness. And then we shall discuss about scatter diagram, how to draw it and how to interpret it. The prerequisite of this topic are uh, measures of central tendency, means, median, mode, and measures of dispersion like range, mean deviation, variance, and standard deviation. So please subscribe the channel and listen the two videos about measures of central tendencies and two videos about measures of dispersion, which have been uploaded in the playlist named Business Stat and Math. So this is in continuation of those videos. So I hope that before you listen this video, you understand that how to measure the central tendency, which are three main measures: mean, median, and mode, and then how to measure the dispersion with the help of mean deviation, range, variance, and standard deviation. Now that when we have when we have completed our discussion on measures of central tendency and on measures of dispersion, then we need to know that what is the value which divides the given set of data into equal parts. So these quartile, decile, and percentiles are alternative ways of describing the spread of that data, including determining the location of values that divide a set of observation into equal parts. Although the standard deviation is most widely used measure of dispersion, however, a standard deviation does not divide the entire set of data into equal parts. So to know that which value divides the set of data into equal parts, we need to understand the quartile, deciles, and percentile. As the name indicates that quartiles mean 1 quarter, so we divide the whole set of data into 4 equal parts, and we will call them quartile 1, quartile 2, quartile 3, and then quartile 4. Decile means dividing the entire set of data into 10 equal parts, and percentiles means dividing the entire set of data into 100 equal parts. So we can say that the 50 percentile will be equal to the quartile 2, because 50% uh, is the median. So 50th percentile of the data will be the median, because 50% of the observation will lie below it and 50% of the observation will lie above it. The formula to find out the location of a percentile in a set of data is LP is equal to n plus 1 multiplied by P over 100. P is the desired percentile. When P will be equal to 50, so this formula will automatically become n plus 1 over 2, because 50 over 100 will be 1 over 2, so n plus 1 over 2. So in this way, we can find out the quartile 2 or 5 deciles or 50th percentile. So all the quartiles and decile can easily be converted into percentile. So if we need to find out the quartile 2, we know that quartile 2 will be equal to 50 percentile. Quartile 1 will be equal to 25% percentile, and so on. Now, this is the computation. To formalize the computational procedure, let LP refer to the location, excuse me, location of a desired percentile. So if we wanted to find the 33rd percentile, we would use L33. So P will be 33, N will be number of observation. So number of observation plus 1 multiplied by 33 over 100. The number of observation is N. So if we want to locate the median, its position is at N plus 1 over 2, or we could write it as N plus 1 multiplied by P over 100, the same formula where P is the desired percentile. This is an example in which there are some brokers who are working in an investment company, and this is data of their commission which they earned in the last month. Here detail is also written that listed below all the commissions earned last month by a sample of 15 brokers at Solomon Smith Barnes, Oakland, California office. Solomon Smith Barnes is an investment company with offices located throughout the United States. So broker number one earned $2,000, second broker earned also $2,000, and so on. And we have how many observations? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we have 15 brokers. So number of observation or n is equal to 15. And now we have to locate its median, first quartile, and the third quartile of the commission earned. So the first step is to organize the data from ascending order to descending order or from descending order to ascending order. Here we have arranged this data from the lowest to the largest value. The minimum commission earned by a broker was $1,460 and the maximum commission which was earned by a broker was $2,406. And now if we want to calculate the percentile allocation of a particular number which divides the set of data into equal parts, we can use this formula. See here. Now we have apply this formula for 25th percentile or quartile 1. Please remember that quartile 1, which is 25% of the total observation, is exactly equal to the 25th percentile. So we put 25 as the value of P and we find out equal to 4. So 4 is the fourth value in that set of data will be the first quartile. So we will see where is the fourth value in that data set. So 1, 2, 3, 4. This is 1721. And here you can see 1721. This is the quartile 1 or 25th percentile. Similarly, the 12th, similarly, when we want to find out the quartile 3, third quartile. So first quartile was, the location of first quartile was 4 and the number of first quartile was 1721. Now we want to find out the location of third quartile. So we know that by third quartile we mean 75th percentile because quarter 1 is 25, second quarter is also 25, third quarter is also 25. So 25 plus 25 plus 25 is equal to 75. So we shall put P equal to 75 in this formula and we find out that location of the 75th percentile is the 12th number. So when we go back in our data and we see that where is the 12th number, 4, 8 and here 2205 is the 12th number. So we will write here that L75, that location of 75th percentile is $2,205. Location was 12 and the corresponding number, corresponding commission is 2,205. And we can say that here that 25% of the brokers earned commission equal to or less than $1,721, while 75% of the broker earned commission equal to or less than $2,205, while the remaining 25% earned commission more than $2,205. Now, when we have completed our discussion on the measures of central tendency, measures of locations, measures of dispersion, now it is a time to discuss about the another characteristic of data, and that is the shape. So measures of central location for a set of observation, the mean, median, and mode, and measure of central dispersion, the range and standard deviation have already been discussed. Now we are going to discuss the shape. There are four commonly shaped which have been observed. Shapes of the distribution, there are symmetric, positively skewed, negatively skewed, and bimodal distribution. To find out quantitatively the value of the skewness, first of all, you should know that the coefficient of skewness can range from -3 up to +3. A value near -3, such as 2.57, indicates considerable negative skewness. A value such as 1.63 indicates moderate positive skewness. A value 0 indicates that there is no skewness and mean and medians are equal and distribution is symmetrical. So if the answer of this formula is 0, we shall call that this is a symmetrical or normal distribution and there is no skewness. However, if answer of this formula is equal to +3, we will say it is positively skewed, or -3, we shall say it is negatively skewed. So now see this formula. This is a formula which is used to calculate the Pearson coefficient of skewness, on the basis of which we divide it into different shapes. So first of all, we subtract the median from the mean, we multiply it with the 3, and then we divide it by the standard deviation. This is a textbook formula. And if we calculate the skewness using software like Minitab or Microsoft Excel, then software coefficient of skewness is calculated with the help of this formula. So if you calculate skewness manually and then you compare it with the calculation made on Excel, you will see a small difference, because Excel uses this formula. So what is this formula? First of all, you subtract mean x from the x, divided by the standard deviation, take the power cube, then you add it up, and then you multiply it n over n minus 1 into n minus 2. This is what Excel does or uses. However, there will be very minute difference if you will use this formula. This is very easy to use. That first of all, take the deviation from the mean, multiply it by 3 and divide it by standard deviation. Here you can see the shapes. This is symmetric distribution. Here 50% observation lie towards the left of the mean and 50% observation lie towards the mean, right of the mean. Mean is 45. This is positively skewed observation. Mean is more than the median. This is negatively skewed because mean is less than the median, and this is bimodal because there are two modes in this distribution. Now this is an example of earning per share for a sample of 15 software companies. This is their EPS. We shall do these calculation on this the earning per share. You know that net income divided by total shares outstanding is earning per share. So software companies earned these values. When we put their data, first of all we will calculate the mean, because to find the skewness we must know the mean. So we are adding up earning per share of all the 15 companies and dividing it by the 15. So our mean earning per share is $4.95. And our now in the next, when we calculate the standard deviation by using the same formula of sample statistic, and our standard deviation is $5.22. We use now median has also been calculated as 3.18. Now we put this value in our this formula and we find out the value of skewness. X bar is 4.95, median is 3.18. We take the deviation, multiply it by 3. We divide it by the n of standard deviation here, and we find out the skewness is 1.017. So this is small or moderate positive skewness. This is not symmetrical distribution. This is positively skewed because value of sk is positive.